Hello everyone, welcome to you all in this presentation. This is Shibbir Ahmed. In this presentation, I would like to discuss about our project, which is titled as a clinically grounded AI chatbot for heart failure decision support using RAG and real-world clinical data. Let's start with the background. Navigating complex discharge notes or clinical trial criteria is still a time-consuming challenge for the clinicians, especially in urgent situations like heart failure. Many traditional AI chatbots often give hallucinated or generic responses, which reduces their reliability and usefulness in a clinical setting. The goal of our project is to design and evaluate a modular AI chatbot that can provide clinically grounded, context-aware responses to queries about heart attacks and heart failure. In this project, we will use Retrieval Augmented Generation (RAG), large language models (LLM) with real patient records and clinical trial data. Let's start the methodology. Here we have developed a smart chatbot integrating various tools such as PySpark, BioBart, and ChromaDB. So as you can see the system flowchart here of our project. First we collected the data. Here we have used two different types of data. Number one, discharge notes. Number two, clinical trials. So we have collected the discharge notes from the Mimic4 database and then filtered them based on the Carlson Comorbidity Index CCI table filter. So associated with a specific condition, which is cardiovascular disease. The condition was chosen by recognizing relevant medical concepts that include congestive heart failure and myocardial infarction. We extracted over 11,000 discharge notes, where 9,000 plus notes contained three sections medications of admission, history of illness, and brief hospital course. Considering the importance of these three sections in the discharge notes, we have converted them into over 26,000 plus small chunks using paragraph-based segmentation. On the other hand, we have retrieved the clinical trials. So here we first retrieve the all eligibility criteria from the completed clinical trials related to heart failure and attacks using clinicaltrial.gov API. We navigated through the nested structure of the API JSON response to extract the important details such as NCT ID, inclusion and exclusion criterion for each of the trial, and then structured all the retrieved tiles in a structured tabular format. And then we dropped the trials where we do not which actually do not have inclusion or exclusion criterion. After retrieving both type of data, having the chunks from the discharge records and also the structured clinical trials, we have converted both type of data in using the BioBert embedding. So thus we have got the embedding vectors. After that, we have stored these embedding vectors into ChromaDB vector storage, and then we have set up the mechanism for the PySpark tools. Here in this case we have used four tools treatment recommendation, symptom reasoning, cause analysis, and trial matching. So say a user query, when a user query appears, a user gives a query, and then this query will be sent to related very closely related PySpark tools automatically, and then these PySpark tools actually will search for this search process actually called the semantic vector search. So you will search related concepts in the vector DB, and then top case similar chunks related to the query will be retrieved from the vector DB and it will be sent to the tool, and then the tool will send the query and original query with the retrieved relevant context to the large language models. Here, in this case, we have used two different models, Llama 3.3 LLM and DeepSeek R1 LLM. So both of these LLMs are based on the with or without RAG mechanism will provide a contextual response. And then we have designed and built the app, and then we have debugged and evaluated the app, and finally we have deployed the app using Hugging Face Spaces platform. Here we have used Streamlit SDK. So actually so as you can see the UI of our chatbot here, if I just go over shortly, like as you can see the setting, we can select the toggle the select the model, and also we can enable or disable the RAG mechanism. Also, you can see the key features of our chatbot, the BioBot embedding, and then ChromaDB vector storage, and the 4 different price per tools: the treatment recommender, symptom cause analyzer, and then clinical trial matcher, and lastly, chat memory symptom reasoner. So now let's talk about the result and analysis section. So in a real world simulation of 50 clinical queries, the system actually achieved 96% routing accuracy with an average response time of 2.6 seconds. All the four PySpark tools worked reliably with both LLM Llama 3.3 and DeepSeek R1 models. The responses generated with RAG were consistently more relevant than those without RAG. As you can see the responses here, like here as you can see, user is providing a query, and then based on the you see the RAG is enabled, and we have selected the Llama model here, and as you can see based on the provided discharge notes, this actually shows that the chatbot actually like searching for the relevant queries in the vector database, and from the after retrieving the relevant context, this LLM's models is providing contextual responses based on the query. So actually as you can see that the responses actually with RAG were more consistent, more relevant than those without RAG. So especially for the treatment recommendation and trial matching. Here, 3 independent clinical reviewers confirmed the system's clarity, practical utility, and ease of use, especially for the non-tech users. This highlights its potential as a decision support tool in a real-world settings. Now, let's talk about the discussions. This chatbot actually useful for different use cases like clinical relevance, like by using real discharge notes and trial data, this chatbot reduces hallucinations and becomes a more trustworthy support tool for the clinicians. Number 2 point, efficiency and usability. With high accuracy and quick responses, the system is useful in a real-world clinical settings where every second counts. Number 3, generalizability. While this study concentrated on heart failure, the modular design allows it to be easily applied to other areas of medicine. Number 4 point, human in the loop. The chatbot is designed to assist but not replace. The final decisions always stay with the clinicians. And finally, the conclusion of our presentation. This chatbot serves as a clinical AI assistant that improves information retrieval in the heart failure care. By leveraging real-time performance and seamless integration with real clinical data, it offers a scalable and transparent framework for LLM-based decision support. So that's all about today's presentation, and also I will attach a live demo of our chatbot that how it works and how the features actually this chatbot supports and provides responses like hallucination free responses, contextual responses with without responses with both of the models selected. So that's all of our today's presentation. Thank you so much for being with us, and please provide your valuable feedback in comments. Thank you so much.